In this video, we're going to work on a slightly more difficult problem. This one, we don't have the scaffolding that we've had in the past, so we have to calculate eventually our centripetal force without first calculating the centripetal acceleration. Part A just asks us to draw a free body diagram of the ball. Okay, so I'm twirling a tennis ball around my head. It's connected by a 1.2 meter long string, which makes an angle of 10 degrees to the horizontal. So I have my ball, and it's affected by gravity. So there's some force of gravity here. Pulling up on the ball is a force of tension in the string. Okay, and that's at an angle of 10 degrees to the horizontal. So part B, it asks us to find first the tension on the string. So just by basic trigonometry, we know that the y, the vertical component of our tension, must cancel out the force of gravity. So F of tension in the y is going to be equal to the force of tension times the sine of the angle, okay, because we're dealing with the opposite side here. We also know that the force of tension in the y is equal to mg, so we can say that mass times gravity equals force of tension times the sine of the angle, and I'm ultimately trying to find the force and tension, so I should rearrange to make that the subject. If I divide both sides by sine of theta, I get the force of tension is equal to mg over sine of theta. Okay, my mass is 58 grams, which is 0.058 kilograms. G is 9.8 and theta is 10 degrees. So if I sub all of those values in, I get 0.058 times 9.8 divided by sine of 10. And now we just plug and chug. 0.058 times 9.8 divided by sine of 10. And I'm making sure that my calculator is in degrees mode here. Which is 3.27 newtons. Part C asks us to find the centripetal force acting on the ball. Now this will be equal to the horizontal component of our tension. Okay, so the horizontal component of the tension is force of tension times the cosine of theta. I can substitute my values straight away here. And again, plug it into my calculator using the stored value to eliminate any rounding errors. So we find that our centripetal force is equal to 3.22 newtons. Okay, now that we know the centripetal force, we can calculate the speed of the ball. We're going to use this equation here for the net force of an object moving in a circle. So Fc is our net force in this case, and that's equal to mv squared on r. We're trying to find the speed of the ball, so I'm going to rearrange this to make v the subject. So I'll multiply by both sides by r, divide both sides by m, and take the square root of both sides. We know m is 0.058 kilograms. We know Fc is 3.22 newtons. And we can find r. We have a string length that's 1.2 meters long. and this is our hypotenuse. We also have an angle of 10 degrees. So with a little bit of trigonometry, we can quite easily find our adjacent side. So our radius is going to be equal to 1.2 times the cosine of 10. If I substitute all of these in, I can find V. And when I put it in my calculator, I'm going to try and use my stored values as much as possible. And I find the velocity is 8.1 meters per second, or the speed, I should say. The average speed is 8.1 meters per second. In part E, we can use this and our equation for velocity or speed to find the period. So I'm using this equation here. V equals 2 pi r divided by t. I'm going to multiply both sides by t and divide both sides by v. And when I substitute, I'll be able to find t. T is 2 times pi times 1.2 cosine of 10, all divided by 8.1. Two times pi times 1.2 cosine of 10, all divided by answer, which gives us a period of 0.916 seconds.